Hey, my friend, do you know what glycans are? They're basically simple and complex sugars that attach to proteins. As you get older, your immune system can go from anti-inflammatory to pro-inflammatory that causes a whole lot of health conditions. And some scientists argue that it's the glycans attached to these proteins and immune antibodies that turn them from anti-inflammatory to pro-inflammatory. On this episode, you will learn what glycans are, how they attach to IgG immune antibodies, and how there's a test on the market which can tell you your biological age as measured by the state of your immune system. Pretty interesting stuff. Stay tuned. If you're liking the videos we're putting out on this show, please make sure to hit the subscribe button down below so you can get notified when we release new videos. Our goal on this channel is to help you look and feel younger and slow down your aging so you can look your best and live your most adventurous life. Are you interested in getting thicker, fuller, and stronger hair? Then make sure to check out fullyvital.com. I've worked with the team there to come up with a whole set of natural ingredients and techniques that you can use to really get thicker, fuller, and stronger hair in very, very quick and short amount of time. So if you want to get better hair, then make sure to check out fullyvital.com. We'll add a link down below as well. Hey, my friend, welcome back to the Anti-Aging Hacks podcast. Today, my guest is Nikolina Lauc, who is a glycan researcher and CEO and founder of GlycanAge. GlycanAge was founded on a promise that healthcare should start with us caring about our health before we encounter a particular problem, and I couldn't agree more. GlycanAge allows you to measure and influence your longevity by looking at an entirely new part of biology. Glycan biomarkers uniquely encapsulate genetic, epigenetic, and environmental factors driving longevity for every human. The test is the result of over 20 years of scientific research in the field of glycobiology, hundreds of research papers, and over 150,000 analysis samples. With that said, Nikolina, welcome to the Anti-Aging Hacks podcast.
Thank you for having me. Pleasure to be here.
So let's start with your background. What got you interested in glycans and this really, small, weird, crazy part of biology to start with?
Well, actually, that wasn't me. It was my father. So he's been in this field for about 3 decades, and they've only been able to analyze this big data sets of people for about the last 10 years. So you can call it new science, although it's not all that new, but it is kind of moving at a much bigger pace than used to. And when he started, I think everybody thought he was crazy to focus on it because everybody was focusing on DNA, and we had perfect tools to analyze it. The human genome was really driving everything. And everybody was neglecting these molecules that we don't even fully understand today. But if you look at the biology of a cell or how our biology works, they're a key component. They're one of the 4 components of a cell. So we have proteins. We have DNA that creates the proteins. We have fat, and then we have the sugars or the glycans. So they're in all of our cells. They're in all of our proteins, and they actually change the proteins post-translation. So after our DNA has made the protein, and we can change gene expression, but then post-gene expression, the glycans change how the protein works. So if you want to understand how biology works, how everything works, you have to look at this last stage of translation in a way.
Mm-hmm. Okay. Well, I have many questions about that specific topic. So before we get started, though, I'd like to ask you about antibodies in particular. And I know that IgG will come up in our conversation, but what are antibodies and why are they important to this discussion that we're about to have?
So they're the adaptive immune system. So it's in a way everything we come across through life. They're a bit slower than the innate. So innate is very quick. It's super fast and kills off our pathogens or even problems we create with our own cells. But then the innate immune system carries these elements of the pathogen and shows them in a way to the adaptive immune system. And these are more sophisticated weapons, which would destroy the pathogen. But also, they keep a part of this pathogen and they carry it forward for life. So it's the immune system we built as we also age. It changes in a way, and it carries everything forward. But when you look at chronic diseases, a lot of them are also related to the immune system because the immune system creates inflammation. And if you look at cardiovascular, metabolic, all autoimmune, really that's all connected to our immune system and antibodies.
Yeah, you're right. And we'll talk about that as well. I got a question for you about that. Now, in terms of, like you said, the adaptive immune system is different from the innate, which attacks all viruses, bacteria, whatever's coming in immediately. The adaptive takes a little bit of time to kind of learn what the organism or the attacker is, and then it creates the antibody, which now has the perfect, the key to the lock. So if we get infected by that thing again, then we have a much faster response and we can fight it off. So it's really, really interesting. And there's so many types of antibodies, but we'll talk about IgG specifically, I think, on this podcast. And I want to tie that into glycans, which again is a key component of what you guys are doing. But what are glycans, Nikolina, and why are they so important in this conversation?
Glycans are sugars or complex carbohydrates. But when we talk about sugars, you are mainly thinking about the wrong sugars. You're thinking about the sugars you eat. You're maybe thinking about how the body responds to the sugars you eat. And what we forget about, or actually a lot of us, at least it hasn't been broadly popularized, is that we are also made of sugars. They're a structural component of our cells. And one way you are familiar with them is that you have a blood group, and you have a blood group because of the glycans from blood cells, which define your blood group. But really, they're everywhere. You have them on fats, you have them in the gut, you have them everywhere, and they have all kinds of different functionality. For us, we look at the glycans on your IgG, which is the most prevalent antibody in blood. So it's about 70% of all the antibodies you produce. And then whenever we look at it, so decades ago, when you would look at certain diseases, you had to know the age of the patient to understand what's going on, because aging was the strongest signal. So I don't think, as glycoscience, I don't think anybody was looking for aging. It was just the strongest signal. It was always there. So when we started looking at these big cohorts and we looked at, we analyzed more human glycans than the rest of the world combined with the 150,000 people from the biobanks, we saw that aging was a huge factor. So we modeled a clock on it, which is really based on how the composition of glycans changes in your antibodies with age. Do you want me to explain?
Yeah, absolutely. Yes, yeah? Please do.
So when we look at them, there's about 50 different structures, and they go into 27 different glycan peaks. And not all of them are related just to age. Some are risk specific, but they would change in composition that you have less of the ones which suppress inflammation, you have more of the ones which activate inflammation. So the composition changes. And you have this type of low-grade chronic inflammation that we call sterile, because it doesn't necessarily need a pathogen, it's just ever present. And it's really a dysregulated immune system. So you would overreact to the wrong thing, or you have this ever-present low-grade inflammation, and you wouldn't shut it down fast enough. So even if you're coming across a pathogen, you wouldn't respond to it appropriately. And with infectious disease, we know that the end stage of that is this influx of inflammation that then leads to the worst outcome.
Okay, so in the anti-aging world, I used to think of sugars as being bad, because once you eat lots of sugars in your meal and they go into your body, they get caramelized and they get added to proteins, attached to proteins, render them useless. So the protein now is not able to unfold, is not able to do its job that it's supposed to. And so we try to reduce our blood sugar levels. We try to reduce this risk of glycation in the body as much as possible. But what you're referring to is different. This is glycosylation, which is that carbohydrates, monosaccharides, polysaccharides attach to antibodies. And this is completely natural. It's not a bad thing, but they also influence the antibody in a way. And over time, this glycosylation changes, and you can measure those patterns as people age, and they're pretty reflective of the age that they're at. And so, what you found in the research is that there's also younger people have younger glycans, and so you can reverse some of these age-related markers, and we'll talk about how to do that. But this is a new pathway we've talked about before. Other clocks that people are using for measuring your biological aging, be that DNA methylation or others. But this is a yet new pathway, or a new marker, if you will, of aging, which is correlated very closely with people's specific ages. Is that correct?
Well, yeah, I wouldn't say new. So the first paper we published was 2013 on the 10th of October.
Mhm.
And the first Horvath epigenetic clock was published exactly on the same date. Okay, I was a preprint, there was a final version,
Okay.
but we were published at the same date. But of course, you can do epigenetics in many different labs in the world. It's quite an established field. For glycans, you can only do it in a couple labs around the world. So they've scaled a little bit slower than the epigenetic side, but it's been here for a while. And just to explain the difference between glycation and glycans, completely different processes. So as you said, this is the body's response to sugar, which is negative. So you have the AGEs, and you don't want that. So that would negatively correlate with your GlycanAge. And for glycosylation, that's actually a regulated process. So we know that for the IgG glycan, there's a network of about 40 different genes which define the structure. So it's inherited as a complex trait. And then also you have epigenetic influences, and it's changed with your behavior and environment. So it's more of a combination of these two influences, and then seeing what's happening right now in the body. And that would, so when we looked at it first, we thought it would be a forensic application because it was such a strong influence. So we thought, okay, can we find chronological age? But it wasn't the perfect measure of chronological age. So you can vary quite a lot from chronological age, and the average variation was around 9 years, which is quite a lot. But the first thing we did, it was the most accurate way to measure a chronological age. And then when we try to see why do you have this variability, why can somebody be older or younger, we can explain up to 70% of it by looking at some traditional blood markers of healthy or unhealthy life. So in men, it was 65% we can explain. In women, it was 70% because of menopause. So there was a huge part of it that so it was a type of biological age or how healthy you were. And then also the part that we couldn't explain, we know that glycans are prognostic, or they would change up to a decade, sometimes before you develop the disease. And this is, for example, for rheumatoid arthritis, they saw this over 3 decades ago, where the glycans, and there would be even causal in disease, they would change a decade before you develop symptoms and you're diagnosed. But we also see this in cardiovascular disease, where the glycans also change a decade before, or 7 years before you are pre-hypertensive. So they're early warning, or they're prognostic. It's not just about where you are now, but it's more about early molecular process, which is leading to this health deterioration, and can give us an early enough warning for us to do something about it before the disease actually happens. Starting with aging alone,
without calling it a disease.
Yes.
Okay. Yeah. That makes sense. Well, thank you for the explanation. I have one follow-on question. So there's the antibody, right? The IgG, and there's different carbohydrates attached to it, the glycans. Is it a matter of more glycans attaching to the IgG? Is it different sites that they're attaching to? What's the difference between a 25-year-old me and a 45-year-old me? Is it just like, is it so much carbohydrates that now the antibody can't do its job properly? What's going on?
You have to have more good ones and less the bad ones. So it's a composition of it. Mm-hmm. And yes, about the attachment, that's interesting. So you'd have something called alternative glycosylation, which is a different glycan binding on a different site, which can be similar to coding mutations. So you have congenital diseases, generally heart conditions that you're born with, which are based on the wrong type of glycosylation. So in a way, you can look at it as mutations, or one way to explain it, it's like, as soon as you have epigenetics, it can be epiproteomics.
Mm-hmm. Okay, got it. I have a question about the inflammatory versus the anti-inflammatory nature of these things. As you mentioned, with aging, chronic inflammation is one of the leading causes of faster aging. It's called inflammaging. And we do know that the immune system can start to attack your own body, your own cells, your own tissues in certain cases of autoimmune conditions like rheumatoid arthritis and many more. And so how does this switch, and is there a way, let's say that you've already contracted an autoimmune disease or you're on the way there as measured by your glycans, is there a way to reverse that once you've started down that pathway?
Yes, you have this general process where it changes naturally with age. So we do see it follows chronological aging in a way, and that doesn't need to be linked to an autoimmune disease. Actually, having less of these anti-inflammatory ones it's more connected to cardiovascular disease and some of the other metabolic related ones. We first didn't know if you can change it. So when we first measured it, that was a big question. Can you actually do something about it? Or are we just seeing that people age in different rates and there's nothing you can do about it? And then there was a study in 2016 in a nursing home where we looked at the glycans and they were put in a mild exercise and diet program, and we saw a moderate decrease. So then we knew, okay, this is something you can actually shift even with lifestyle.
Okay, so we talked about glycans, we talked about how they attach to IgG, and we talked about how they change as you age, and that there's inflammatory portions of this and anti-inflammatory. So you want them to be as anti-inflammatory as possible, and your immune system supporting you instead of attacking and hurting you. So that's important. We talked about the difference between glycosylation and glycation, which are two completely different things. I just learned that recently. Thank you for the explanation. And you mentioned, Nikolina, that there's 3 or 4 components that make up or influence these things. There's genetics, there's epigenetics, and there's lifestyle or environmental factors as well. Is that fair? Those are the 3 top ones?
Yeah, those are the 3 ones.
Okay, and this technology was also released at the same time as the other epigenetic clocks on the market. So it's it's still new, but been around for a few years. Okay, so now let's get into, I guess, in that segue, let's get into, we know that as we get older, these things change, not for the better usually, but there are some interventions that you have learned of or come across which allow us humans to reverse some of this aging in. And so there's a few of them. So yeah, let's get started first. Which ones would you like to go with first?
Well, I can start with where the research started and what we found, and some was quite surprising. So first thing, after we did this nursing home study, the first idea was, okay, if everybody goes in an exercise regime, will we make them younger? So we did a big study looking at 1,000 people going to the gym for the very first time. And they were in their 40s and 60s, going from a sedentary lifestyle to the gym, trained by young PTs, going on an intense exercise and intense diet program. And we followed them for a year. And all of them kept getting older, or the majority of the cohort kept getting older. And we had no idea what was going on, because this was the number one thing you do for your health. You go on a diet and you go to a gym at the same time. So
especially in the beginning of the year, right now, January.
Particularly now. Yeah, everybody's doing it right now. And, the gym industry is 30, 40 years old. And they've always seen this influx from, I think, January to March or April, where they make 40% of all of the revenue. And then magically, everybody, still pays for, they still are signed up to the gym, but nobody really goes. So
yes, exactly.
I even think their model is, that's, but unfortunately it doesn't work. If you're looking at how much our health has improved because of the fitness industry, I don't think they've quite achieved what they intended to. And we didn't understand it until we looked at smaller sports cohorts. And weight loss. And when we looked at the first cohort of a group of men in their 30s doing interval sprints, we followed them and they were just doing interval sprints, followed them for 3 months. All of them got younger. So exercise is good. Why was it bad? And then we looked at bodybuilding, and this was in women. And we followed them before and after competing, and there was a control group as well. And they all got pro-inflammatory. Their biological age went up, but we also looked at gene expression. We looked at all of the different immune cells. We had other biomarkers, and everything would change in a negative way, but also the women would lose their cycle and they would lose bone density. So in a way, it mimics aging by the immune system, mimics menopause in the short term, and also osteopenia. So over-exercise is aging, or it is leading to the wrong way. Of course, they recovered. So the segment that didn't diet recovered quicker. Well, the segment that was in a caloric restriction diet and exercise program at the same time, they found it very hard to recover. And then when we looked at weight loss and caloric restriction, it was just positive. So we looked at...
Actually, can I ask you a question on the exercise? So men that were doing interval trainings or sprints, which by the way, I love doing because I was a soccer athlete in college and growing up. And so I still do those to this day. I find a track and just go run like, 10 or 15 times, all out sprints. But so that's obviously been linked. It's so important, just with general other information that we have about health and wellness, that sprints and going all out really helps boost a lot of your cardiovascular markers and health markers overall. But we're finding this in your GlycanAge tests as well, in terms of having a positive impact. Now, you mentioned about overtraining, and especially women bodybuilders. And I know I'm not a bodybuilder, never was, but there's a regimen you have to follow. You're training for hours. You have to shred every millimeter of fat out of your body. And so I imagine it's very, it's a lot of work that you're doing all day. And so that is where overtraining comes in. And Nikolina, the obvious question people are going to have is, well, what's enough training and when am I going overboard and I'm overtraining? And I know now in the health and wellness world, there's people that listen to the podcast, hopefully, they're wearing devices like the Aura Ring. They're wearing other, heart rate monitors or chest straps that tell you heart rate variability, which gives you a good indication of whether you've recovered from the previous day or not, and whether you should take it easy or you should keep going based on your nervous system. But if people don't have those devices, how would they know what a overtraining is or what just regular training would be?
Actually, I believe it's very hard to measure. And also, you can feel very good with this level of low-grade chronic inflammation, actually. So, and the exercise gives you all these positive hormones as well. So it becomes, even the pain becomes a little bit addictive. Mm-hmm. But the pain is inflammation in a way. And we're always looking at chronic inflammation because the glycans have a long half-life. So it's always something that's staying there for a longer period of time. And what we know as a general rule is if you are in a caloric restriction diet and exercising at the same time, that generally seems to be negative. Everybody sees a change. It may not feel like it's very negative, but we do see a change on a molecular level. And that's probably because we call it energy insufficiency. So you're building, so if you're doing sprints and it's acute stress and you are building new muscle tissue, but you allow it to recover at the same time, and you feed it properly, then yes, you are building healthy muscle. But if you are building muscle and you're not feeding it properly, so you're in energy sufficiency and you're not recovering properly, that's probably not healthy muscle. You're probably accumulating scar tissue in the muscle, which is pro-inflammatory, which is why we think a lot of the professional sports, it's quite hard to combat it. Of course, there's athletes who have phenomenal scores and phenomenal longevity, but they are doing a lot for their recovery and their nutrition to be able to perform at that level and not create the damage. Generally, if you are doing competitive sports, you are creating damage and your body is spending itself in that period of time and has the capacity to recover, but some of this damage will accumulate as well. And the level is probably very unique because you have training age as well, because you can get used to a certain number of hours of training and be perfectly fine doing it. And there may also even be some gender differences in terms that maybe fasting and exercising as a woman is not so good. Well, for men, they cope with it a little bit better.
Yeah. Okay. Got it. Yes. One of the top paid athletes in the world, Cristiano Ronaldo, actually sleeps for a full 12 hours, which is crazy. That's a lot of recovery, but I guess he needs it because he's doing so well at this age, even at the top stage in the world. Okay. So let's move on. So that was number one, is over-exercising, overtraining can lead to a deterioration in your GlycanAge. And, you can reverse it by coming back into balance. And okay, so that's number one. What about number two?
Weight loss.
Let's get into
weight loss. Okay, so that's an obvious one. I think if you want to prove that biomarker works, you first need to look at the things which are good for our health. They're obvious. There's a lot of other information, a lot of other data there supporting that this is good for you. So we looked at weight loss both longitudinally. So we observed 2,000 twins over 2 decades, and we see that if the twins are gaining weight, they age faster. If they're losing weight, they age slower. And this is true even in identical twins. Then we had a cohort on caloric restriction, and caloric restriction on its own also produces gives you more positive glycans and reduces your immune age in a positive way. And if you have dramatic weight loss. So this was actually bariatric surgery where they would lose sometimes 20, 30 kilograms in 6 months.
Wow.
6 months post-surgery, they reduced an average of 9 years by biological age as a cohort. Of course, this varies. Somebody would reverse 2. We had a person who reversed 30 something. And the problem with bariatric surgery is that you haven't changed eating habits generally. So if you look at them a few years post-surgery, they are back to square one or
Yes.
regain
Yeah.
most of the weight. So it's not but as a proof point, if you lose a lot of weight, you can completely reverse the damage that's been created with the excess weight.
Mm-hmm.
So
Yeah,
weight loss works for them.
Okay. Yeah, I've come into contact with people that have had bariatric surgery. There's friends of mine that are in groups, Facebook groups, where thousands of people are getting it. And I only pose one question to them. Okay, fair. This is what you want to do? No problem. It's easy. But 18 months out, like 95% of the people are back to their original weight. So why did you do it in the first place? It doesn't make any sense to me, at least, but I don't want to speak for folks that are doing it. So yeah, so you said after 6 months of bariatric surgery, 9 years of reduction in the immune age, so to speak, generally, not specific individuals, but some had more, some had less. And when they regained the weight, they got it all back, meaning they were back to square one. So it seems like this marker can reverse. Weight loss is a big marker for this, and you can reverse if you lose the weight. And if you don't gain extra weight, then it'll be younger than people that are older or that are bigger than you or that have more weight. Okay, sounds good. What else?
Diets.
Mm-hmm.
So next, after weight loss, we thought, okay, so this works. Can we find the one diet that will fit everybody, and we should all follow this magic longevity diet? And we looked at 1,000 people on 5 different diets over a year, very well controlled. So the meals were made for them, different nutrient proportions, so from high protein, high carb, and different combinations of all of these. And in each of those cohorts, you see half people have significant benefits or positive changes, and half have negative. So it was pretty much 50-50, with a little bit more, like there was a caloric restricted one that just had a more general benefit. Mm-hmm. So we're very individual in how we respond to foods. And this is why there's probably such a big debate in the nutrition space, where it's one diet and it's another diet and there's a new diet. We're very individual. Maybe that's a great diet for you, but there's never going to be a one size that fits all. Going at general advice, and we can't yet tell you in advance what will work. So now you can experiment with it. So you can go on a 3-month diet and test before and after and see if it's actually worked for your longevity, or if it's done the reverse, because that happens pretty often as well. Right. One thing that could be general is improving your gut health. So if you're improving, and we know this from clinical data, because it's the only kind of data we can get hold of, but we're hopefully going to do more lifestyle ones now. Fecal microbiome transplant, which is transplants of microbiome from a healthy person to somebody with a chronic condition. And if you fix the immune system in the gut, you also fix the immune system in the blood. So fixing your microbiome will work for change your biological age and work for your longevity. Now, we don't have enough hard scientific proof here, but we have lots of individuals who did self-experiments, so NF1 experiments, where they would increase the diversity of plants in their diet and then remeasure after 3 months, and they would see a significant reduction in their biological age. And this is a very simple hack. You would think this is too simple. This is what grandma told, eat your vegetables. So it wasn't, but if you look at how it works, and I think it has to be local plants. So if you are eating lots of local plants, you're informing your immune system about your environment. And if it's well informed, it creates less inflammation, because anything new, you respond to it with inflammation. But as you get familiar, you create less inflammation. So it could be a very simple one that could work for more of a general view that anybody could apply, which is what
that's a great tip. Obviously, gut health is so important these days, but it's being corroborated and verified by so many different angles. I typically recommend highly to people that they ground often. So they go outside and, spend time barefoot on the grass, on the earth, just connecting with all that's out there, and it reduces inflammation. And there are studies around it, but also you get contact. Your skin gets contact with all the germs and just the bacteria and everything that's out there. So you're one with the environment, not living in your air-conditioned flat and never touching anything that's green. So, like you said, it's just becoming more in tune with nature that's around you. I think it's a good one. Okay, there's one more. I believe it has to do with hormones.
Yes. So that's a bigger topic, but we always saw quite a big gender difference. So when we would look at how the immune system ages, men were very linear, so they just accumulate the bad, lose the good in a straight line. Women had a curve, so they would have, in a way, less inflammation in reproductive age, and then they will have a very rapid shift as they enter menopause. And in some women, it's a bit more dramatic, in others, it's less. So the average change in your biological age from perimenopause to menopause is about 9 years, but it can go from 5 to 30. Mm-hmm. So there's always this gender difference. And we had one trial a few years ago done in the States where they would block both men, but let's talk about women first. They would block hormones, and then they would give them a placebo or an estrogen patch. And we saw that the placebo group would age also rapidly, so about 9 years within 5 months, while the estrogen patch would completely not age or stay in the healthy range. They did the same thing with men, and then they recovered post that because they were given the IVF hormones to stop hormones for a period. And for men, they also blocked hormones, and they gave them testosterone, or they gave them testosterone plus an aromatase inhibitor, which blocks this conversion from testosterone to estrogen. Mm-hmm. And if they just gave them testosterone, also they wouldn't have the negative changes. But if they block the conversion, they would become more pro-inflammatory and age. So even for men, it's the estrogen, which was actually beneficial. And recently there was a nice mouse trial where they gave them a type of estrogen which doesn't feminize them. So it's a alpha 17 estradiol, mm-hmm. and it extended their lifespan by 20%. So estrogen could be an interesting longevity drug overall.
Yeah, that's very interesting. I know we talked about this before the interview about how the Women's Health Initiative had, the findings that they did, and they shut down a lot of estrogen, which was not bioidentical, I believe. And so I'm I used to not be in favor of hormone replacement therapies a few years ago, but now I'm totally open as I'm learning more and more data on how they can be safe. And I know plenty of men that are on testosterone well before they should be, but hey, that's what they choose to do, and it's their body, so it's fine. And I know women, especially around the menopause age, there's just so many factors and so many health markers that go down very quickly around menopause that there's definitely value in figuring out what's best for your body and doing that. But what you're saying is estrogen supplementation through whatever way into the human body for men and women has shown a positive correlation with the immune age.
Well, for men, we tested testosterone, so it's the conversion to estrogen. We don't know if estrogen alone would help men or what type. Particularly, they don't want the one that would feminize them. This was I don't think we found a solution for humans. But we also have now data we're collecting, which is post-menopause or around perimenopause to menopause, following menopause clinics, and what happens when you start therapy, and then through natural menopause, we follow you, and these are body identical hormones. So in the UK, we call them body identical because they're also regulated drugs, so they've been in proper trials. And after 3 months, we would see that they reduce about 7 years on average. After 6 months, they reduce 10. And of course, as you said, the Women's Health Initiative caused a lot of, and another problem with menopause is the same problem we have with aging. It's natural. Every woman is going to go through it. So you don't think of it as a condition. It's the same as aging. Oh, it's natural. We shouldn't be treating it. And we don't see it as this inflection point of disease, that if we tackle it early, we can prevent all of these diseases coming later on. And particularly for women post-menopause, they have a lot more chronic conditions than men, and all of it is linked to declining hormones. And if you look at it, it's a hormone deficiency. It's an organ they use to create these hormones that you have receptors for everywhere, brain, lungs, skin, everywhere. And now it's depleted quite dramatically. So the organ is literally not there anymore, it doesn't function. So it's a hormone deficiency. Unless you tackle the hormone deficiency, all the other systems in the body will suffer. And even if most women have symptoms, about 85% of women have symptoms, a lot of them related to mental health. So I think there's been a big mistreating of menopause now, where for years they would suffer with anxiety, depression. They're just given antidepressants, not what they actually need. And I think that's slightly changing now. I think there's a bit advocacy, but there's still a lot of fear. There's still a lot of people who haven't actually read the data and looked at what was found before, which wasn't a significant risk. And also the drugs are so different that I think that needs a little bit debunking, so we're more comfortable with it. And part of it, I think, was political. It was the same thing. It was natural. I should just suffer through this. Everybody's gone through it. I shouldn't do anything about it. So I think we need to rethink that.
Okay, yeah. And on this show, we talk about or bring on people that want to live much, much longer lives, including myself. And I imagine a future where we could be 150 if we choose to. And if you go into menopause at 40, 50, 55, then you're going to live 100 extra years post-menopause. And that's of course, it's your choice as a woman, but I would imagine that women would want to live like they're 25 or 30 for a longer time. And I certainly would. So anyway, so that was the fourth item. Are there any other interventions or any other tips or tricks we could use to reduce the immune age?
So we're looking at lots of different drugs and supplements at the moment. I can't say that there's any really hard data I can stand behind and say, yes, this 100% works, and everything needs to also be replicated or be a placebo-controlled trial. But we had one with eggs, which were fortified with omega-3, and they had a positive influence on your glycans. So balancing out the omegas could be a significant thing. Mm-hmm. There was another one with vitamin D, but I don't think that was very significant. It had a mildly positive effect. And from all of the longevity drugs, I also don't know, because we're just starting the trials, although we do have a bunch of case studies with metformin where they would see a significant change. But we still don't know if that's just the group that has this sensitivity towards diabetes, because a lot of them they weren't diabetic or pre-diabetic, but they did have this dysregulated glucose. So if they would fix that, then yes, their biological age would improve as well.
Okay, sounds good. So then let me ask you about the test that I believe your company has developed. It's called GlycanAge. I've taken it, maybe 10 days ago, and I sent it in. So I don't know where it is right now. And I'm awaiting my results whenever they are out, and we'll see how they are compared to my chronological age. And then I might email you and ask for some tips, but hopefully they're going to be on the good side. So we'll see. So let's talk about GlycanAge and how you came up with the test and why people should use it.
So this has been around for a while. We've only been on the commercial market for about 2 years now, but we've been testing ourselves, our scientists, and a bunch of people around us for a while, and including all the research. One thing where it's most useful is inspiring you to make a behavioral change, and also to debunk that something you were doing for your health may not have been the right thing. And just to more precisely guide, because everything we're doing for our health is really for our longevity. So if you're going to the gym, if you're following a diet, some you may be doing just for aesthetics, but most of it you're doing for your long-term health. And if you're doing something for your long-term health, you want a reliable, non-biased way to measure it. So it took us a while to develop something that's easy to do. It used to be that you have to go to a clinic and draw blood, and then that gets sent to the lab. Now we have a home kit, so it's very simple. It's 4 drops of blood. It can be stable in the post up to 2 weeks, so we can ship it quite internationally. And then that goes to the lab. It's 10 days of chemical steps. So we fish out the IgG, we cut off the glycans, and then we look at all of them individually and analyze the composition. And then you have a biological age, but we also interpret all of these different structures for you. And you don't need to ask me for any tips, because each test comes with a consultation with a specialist. The specialists you either get a general specialist if you haven't filled your health profile, But if you filled your health profile, then we customize it. So you would, based on a certain algorithm, you would be recommended a certain specialist, which will focus nutrition, sports, mental health, hormone balances, depending on where you have the highlights in a way. And then you can also have it as a one-off. So you do a test and you have a consultation, you just know where you stand. Mm-hmm. Or you can do it as a follow-on, where you have the initial test, then you make a change and you see how that's actually had an impact. And that is the best way, because you can really, you can have this positive reinforcement of what you're doing is actually making a benefit. And we see that that works the best way. And even if you learn that you've done a mistake, you've learned that you've done a mistake. And usually it's very logical, like fasted and exercised at the same time, and I thought it wasn't a caloric restriction, but actually that's the same thing. But at least it gives you that insight.
Mm-hmm. Okay, got it. That makes sense. Now, I have a couple of parting questions for you. I know I wrote them down. What is so I'll come back to, I guess, the folks that you are measuring. I believe you'd mentioned there's some differences in ethnicities and genders when it comes to the immune age. What I guess, what are the outliers? Are there certain ethnicities that are not doing well, or countries, and the ones that are doing exceptionally well?
So we did a study together with the Human Glycan Project, where there was about 30 different researchers who collaborated, and we looked at 27 different populations around the world. Lots of European, but also some parts of Africa, Asia, America. I believe we had Australia as well, and Thailand. And we saw that the glycans correlate with life expectancy in a certain country, but they just as highly correlate with the development index of a country. So in a way, the socioeconomic impact, even if you had a wide baseline in multiple different places, the socioeconomic impact was the biggest factor. In the UK, we also had a biobank which had few generations of immigrants. And we looked at all of them. So this was Indian, Black, and white immigrants. And in the first generation, they look like the first country. In the second generation, their immune system, or the glycans, would start to look like white Brits. So that's a huge influence by the environment.
I got you.
So of course, there's both sides play a bit of a role, but socioeconomic and your environment would have the most significant impact, if you ask me.
Okay. Nikolina, what do you see as the future of glycans, if you will? I know there's people doing, the implants into their gut, but fecal transplants, I should say. But could we develop some kind of, billions of, I guess, glycanated IgGs that are perfect 25-year-old and just inject them once every quarter? Is that something that we're going to look at in the future? How do you see this playing out?
Well, there's lots of different things that are being developed. One is on the diagnostic side. So aging is like a door for us into glycans. And then from there, we can actually look at all of these different structures, and some of them are specific to certain risks, like metabolic, cardiovascular, and neurological. So as we go further down this path, part of it also being regulation, we can give you so same as you have a genetic report, we can give you a much more thorough look at risk related to these glycans, which incorporate genetic and what's happening at the moment. So it's not something where you would say, oh, I have this risk and that's it. It would be, I have this risk. It's a very long time frame to respond. I can moderate this risk. I can control it. And even when it happens, it won't be a surprise. Because right now, when we diagnose diseases, we actually diagnose them in the final stage. So it's when you do a blood work, all the tests are focused on identifying an organ that's not working properly, and then you name this as a disease. But actually, on a molecular level, this starts a decade before you actually get to this phenotypic change. So that's one future. One future is more precise diagnostic, but also prognostic. So we're not really looking at the endpoint disease, we're looking at the starting point, and we're preventing it for as long as possible, which starts with lifestyle. Second point is potentially therapeutics. So this is a very new field. So as you had this IVIGG, which is used a lot yet. I wouldn't say it's very safe, but it is used a lot and it makes people feel better for a good period of months, but you would need to do it frequently, and I wouldn't say it's very safe. But we had mice studies where mice were given a precursor to a certain glycan structure, and these were mice who were fed a high-fat diet, so they become obese and they develop hypertension. But if you fed them this mannac, which was a precursor to sialic acid, they would become obese but wouldn't develop hypertension. So you can prevent the hypertension in mice. This still needs to be validated in humans. There could be many different glycan-based therapeutics, needs to go for rigorous trials, and also first to see, does it have a benefit for healthy people, or is it just people who are at risk of developing it? And then what was the other one apart from this? In terms of clocks, so in terms of clocks, that's an interesting one. Now we, as you said, we customize it as much as you like. So you can report your ethnicity or gender. You don't need to. We just put you on the broad baseline. So that's your choice if you want a bit more customized. But in the future, you'll have highly personalized biomarkers, biological age as well, where you're really looking at what it is for this individual. Because right now we plot you on this population. Of course, we can expand their data set more and it will become more precise, more and more precise as the data set expands. But if you can actually track an individual from maybe early 20s and then customize something which is really based on him, and then you can really give them this incredibly precise, hopefully, metric for it. But we're, that will take some time until we get there. But that's kind of my vision, where we get to the super precise way of doing it.
I hope it just doesn't take 20 years because a lot of people are ready for it now. But I understand there's regulation and safety and all that we got to go through.
It's functional now. So as it is, I was very happy there was this independent study that was done without us. It's great when somebody else does something for you, but they looked at all the different biomarkers we have to measure aging. So from two types of DNA methylation clocks to proteomics, metabolomics, glycans. They modeled a clock on all the clinical biomarkers, and the glycans and epigenetics moved with general aging. So they were the most general biomarker. They were not risk specific, but the acceleration of your GlycanAge by 1 year was most predictive of future hospitalization within a 10-year time frame. So it's very useful now. If you're doing something, you're reducing your risk, and you have a very long time frame to reduce your risk.
Yeah, absolutely. Catch it early and slow it down or reverse it even. Okay. Thank you, Nikolina. This has been fantastic. Thanks for sharing the complex topic of glycans, antibodies, and how they work together, and immune age in particular, and how you can measure that with a test that you guys have played a big part in developing. So I've taken the test. I'm waiting for my results. So I'll get once I get them, I'll get an expert opinion on what I need to change if there's any red areas, but I'm looking forward to it. So thank you for coming on the show. Where can people find the test, and where can they find you?
They can go on the website. So it's GlycanAge.com, and you have all the packages there. We work with multiple clinics. So we have about 150 clinics around the world who are working in most functional medicine, longevity medicine, integrative. There's a few of them listed on the website, but we'll have a very comprehensive list come out in the next couple of weeks. And for me, I'm not much on social, but LinkedIn. So just my name on LinkedIn, and usually you can find me there.
Okay, sounds good. Well, thanks so much for coming on again.
I appreciate you. Thank you for having me.